Hey, anatomy students, Mr. Yance again. Going to go over the internal parts of the heart today, which will not only help you on the test coming up next week, but also the dissection we're going to be doing next week, because we're going to dissect the heart in lab, and you're going to have to know the parts of the heart after you dissect it. So that's what we're going to go over today and tomorrow. So I just want to start with a little introductory video that I won't show all of it right now. I just want to show the parts that we're going to go over today. So I'll introduce it. I'll let this guy explain it a little bit, and I'll go in a little more detail with notes. So here we go.
About the size of your fist, the human heart is the most important muscle in the body. It can beat more than 100,000 times a day, pumping about 2,000 gallons of blood through a 60,000-mile network of vessels in the body. The human heart is made up of four major chambers: the right atrium, right ventricle, left atrium, and left ventricle. The right side of the heart receives blood that is low in oxygen from veins all over the body. It then pumps the blood through the pulmonary arteries into the lungs, where it will become reoxygenated. The left side of the heart receives this oxygen-rich blood from the lungs. Then it pumps the blood through the aorta back out to the rest of the body through a complex network of arteries, arterioles, and capillaries. While blood is circulating through the body, it delivers oxygen and nutrients to tissue through the capillaries, and at the same time picks up carbon dioxide and other waste material. The veins return the deoxygenated blood to the right atrium, and the cycle begins again.
Okay, so I want to stop it there because that's what I want to talk about today. Let's just look at the basic parts of the inside of the heart, and then later on we'll go over the blood vessels. I think the hardest part of dissection of the heart is actually not finding the chambers and the valves and those things. The hard part is finding all the different blood vessels, because a lot of them look the same. So I'll spend a little extra time on that probably either today or probably tomorrow. So what I'm going to try and do is show you a diagram, which will be on your test. And then also the real thing. So I'm going to show you both, and this will really help you for when we dissect the heart. So let's start. I want to mainly focus on the right side first. So the right side of your heart, now remember, that's your right. Basically, that receives deoxygenated blood from the body. The head and the arms will drain from one part, and then we're going to bring up blood from the bottom, your legs and toes and things like that. And then they're going to all dump into what we call the right atrium. So the right atrium receives deoxygenated blood from the body. And then there's a tricuspid valve between the right atrium and the right ventricle. That's the other chamber on the right side. Low pressure. If you're going to have a heart problem, not that you want to have a heart problem, but the right side would be a much better place because it's low pressure, okay? Because it's barely getting back to the heart. The tricuspid valve has three flaps, thus the name tri, and it basically is between the opening between the atrium and the ventricle. And what it does is it prevents backflow. So you want blood flowing one direction. You don't want it going backwards, okay? If it goes backwards, you get a gurgling sound. That's called a murmur, all right? So when you look at the right side of the heart, we'll go over all these blood vessels later, but you're basically just dumping into this right side. And you can see we always illustrate it with blue so that you can see that's deoxygenated blood. And here's the thing. So this should look eerily familiar, and I tried to label it using a color code. So the right atrium is up here, what I have in yellow, okay? And there you can see the tricuspid valve, and that's going to prevent blood obviously flowing backwards. That's kind of the idea. That's where we're going to start. So we have deoxygenated blood. On the real heart, that's this space up here. You can see it. So it looks very similar to the diagram, and there's the tricuspid valve. And it's going to be hard to see, but you should see three flaps there. All right. Now, there's some other things inside there too. So in the right ventricle, the bottom chamber, there's something called the chorda tendenea, which is also on the left side, and the papillary muscles, which are also on the left side. So I'll go over them here, but I'll come back to them on the other side of the heart because they do the same thing on both sides. The chorda tendenea is they're connective tissue, they're tendons, they anchor the tricuspid valve. I like to think of them as like parachute cords. They literally are hooked to that valve, and then they come down and they hook to this papillary muscle, which is also on the right and left sides. What's crazy about that is that's what's going to pull down and release, pull down and release. Think of it like a parachute. So think of the valve as a parachute, the cords, and then you got the muscles at the bottom. All right. And you can see that here. What I have in green are the chorda tendineas. When you dissect, I'll show you a picture in a second. They literally look like cords, okay, parachute cords. And then at the bottom, anchored in this huge right ventricle, this space, ventricles and atriums are just spaces, we have these papillary muscles, and they're going to pull down on the cords, and that's what controls your heartbeat. So we pull down, we open up the valve. You saw that from the video. Blood shoots in there, boom, they snap back shut. That's the idea behind these, okay? So you can see from the real picture, there's our parachute, our tricuspid valve. There's the chorda tendenea as they really show up well on this video on this side, and then the papillary muscles are down here at the bottom. And then there's this space. So there's the right ventricle, right atrium. There's my tricuspid valve that separates them. There's the cords and the muscles that open and close the valves. Okay, and you literally can hear that blood pulsating through there with the stethoscope. All right. Low pressure, you're going to notice that we have a little thicker muscle on the left side than the right. I want you to kind of pay attention to that. I'll talk about this later, but there's a septum which separates the right from the left side. Some people have problems with holes in that and deoxygenated and oxygenated blood mix, and they have to go in there surgically and fix that. So the septums is like, think of it like a big wall that separates them. Okay. Now we have the same thing on the left side, except the valve is a little bit different. Okay. On the left side, we have oxygenated blood, high pressure, low on the right, deoxygenated blood, high pressure on the left. So what we do is we pump the blood out of the right side to, I'll go over the blood vessels later, through pulmonary arteries. They're going to pump deoxygenated blood to the lungs. We chock it full of oxygen and we pump it back to the heart, to the left side, and that's where we're going to dump in oxygenated blood. Okay. This side only has a bicuspid valve, two flaps. We normally call that a mitral valve. You may have heard that before. Okay. We also have the chorda tendineas and the papillary muscles. Again, they're the same thing. Okay. So that's why I just wanted to cover them in that one before. There you can see. So now I got the left side. There's the left atrium. There's my bicuspid. See the difference? I got 3 on this side, 2 on the left side. The cords are the same. The papillary muscles are the same. And the left ventricle is just a little more thickly muscled and a little bit, about the same size of chamber. The difference is I have oxygenated blood instead of deoxygenated blood. You look at the real heart, same thing. There's my left atrium. There's my valve. There's the chorda tendenea. There's the papillary muscles. And there is my left ventricle. Okay. So it's very, very critical when you dissect that. Number one, we dissect so that we're going to open it up, kind of like opening up a car door. We want to cut the right direction. I will help you with that when we get over there next week. And then you'll find all these parts. Okay. Not hard. I mean, it's pretty straightforward. I kind of showed you there. The chambers, there's the lower cavities, right ventricle and left ventricle. So that's basically the inside of the heart, and you'll understand it even more after we do our dissection. And hopefully we'll take a little lab quiz over the parts. The last thing I'll wrap up notes with today is endocardium. That is simple squamous tissue that lines the blood vessels. So what we have is endocardium. We have myocardium, that's actually the muscle itself. We have the epicardium we talked about the other day, where that covering on the outside of the heart. And then we have that septum. The septum is what, again, going back to this picture, is what separates, huge, you can't miss it, you'll cut through that. It separates the left side from the right side, but better yet, it separates the oxygenated blood from the deoxygenated blood. What you don't want happening is you don't want a mixing, you don't want valves that don't close. Think of a leaky door. You want the door to shut tight. You don't want to have backflow of blood. That's a murmur. We'll talk about it later. You don't want to have mixing of blood, because that's going to lower your oxygen content and you're not going to get enough oxygen to the parts of your body. We have issues with that sometimes. Most of the time, things work really well. Blood comes in this side, goes out to the lungs, comes back in the left side, out to the rest of the body. So you got blood coming and going out of the heart, but the idea behind heart function is that we keep that blood flowing one direction. That way we keep the oxygenated and deoxygenated blood separate, and we keep things working like they're supposed to. And think about how important the heart is when you're talking about, all the gallons of blood it's pumping every day and 70 beats a minute, 24/7 your entire lifetime. You can't have a heart not functioning correctly. All right. Okay, we'll go to the blood vessels tomorrow. That's going to take me a little time. I want to go through all this this week. So we'll get through the bulk of the notes, at least the internal parts and the structures the next day, or today and tomorrow. And then we'll go over and dissect it. And then I'll wrap up with a little bit about the electrical system of the heart. And then we'll take our chapter test and move into CPR. All right. Hey, I hope that makes sense. As always, if you've got questions, shoot me an email. And we will pick up there tomorrow. Okay. Have a good day. See you. Bye.